This video is about center of a group. Say G is a group, then the center of the group G is denoted by Z of G, and it consists of those elements of the group such that Hg is same as G times H for all G in G. Meanings that center consists of those elements of the group that commute with all other elements of the group. So we will prove that center of a group is a normal subgroup. So first we see that identity is in the center of the group because E times G is same as G times E, which is same as G for all G in G. So which shows that Z of G is non-empty. Then if there are two elements H1 and H2 which belongs to the center of G, then we will show that H1 times H2 is again in the center of G. So to prove this, we will consider that H1 times H2 we will multiply with an element G, and this will, because H1 is in the center, H2 is in the center, they will commute with G. This will give G times H2, and this is same as G H1 H2. So what we have done, first we have commuted H2 with G, and then we have commuted H1 with G to get G times H1 H2, which shows that H1 times H2 is in the center of group. Next we will show that if H is in the center of group, then H inverse is also in the center of group. So for this one we consider H inverse G, and we can write it as a G inverse H whole inverse. So here we have used that AB whole inverse is same as B inverse A inverse. Yeah, so we have used this property here, and then we know H is in the center of group, then it commutes with all other elements of this one, which means that H times G inverse whole inverse, and which is equal to G H inverse. We have again applied this property, yeah, which shows that H1 is in the center of G. Yeah, this shows that center of G is a subgroup. And for a normal subgroup, we need to show that if H is in center of G, then G H G inverse is also in the center of G. So we take G H G inverse with any element y in the group, then we can write this one as H G G inverse dot H, because H is in the center and we have commuted H with G here. And because this one is identity, which means that this is same as H E times Y, which is H Y. Now we will compute Y times G H G inverse, which is same as Y times H G G inverse. So we have again applied that H is in the center of group, and this one is same as Y H E, which is Y H, and because H is in the center, this is same as H times Y. So from these two equations, that Hy is same as Hy, which shows that these two things are same, and which particularly shows that G H G inverse is in the center of group, which indeed shows that center of G is our normal subgroup.